So now let's take problem based on psychometrics. So I am writing the problem here first and then we will solve it. Atmospheric air, atmospheric air at 1.0132 bar has a dry bulb temperature of 32 degrees centigrade and a wet bulb temperature of 26 degrees centigrade. Specific humidity is 0.0186 kilogram per kg of dry air. Compute A, the partial pressure of water vapor, the partial pressure of water vapor. B, the dew point temperature, the dew point temperature, C, relative humidity, D, the degree of saturation, E, the density of air in the mixture, F, the density of vapor in the mixture, and G, the enthalpy of the mixture, So in this problem, we have to find almost all the properties related to the psychometry. So this one will be the very useful example for applying the different formulas for calculating different psychometrics properties. So now let's solve the problem. So I am writing the solution here. In that problem, specific humidity, that is W, is given 0.0186 kilogram per kg of dry air, that is given in the problem, and we have to find out first partial pressure of water vapor. So we know the specific humidity is nothing but 0.622 Pw divided by P minus Pw. Now we are solving the A part. So W I am having 0.0186 equals to 0.622. We have to find out Pw, and here we have to take the atmospheric pressure, that is P, that is 1.0132 minus Pw. So now P here I am assuming that is 1.0132 bar. So here simply I am applying the formula for specific humidity and I am just putting the value here, and in that problem we can easily get here If we solve it, so I am having 0.0186 divided by 0.622, so I will get 0.0299 equals to PW divided by 1.0132 minus PW. So if we multiply 0.0299 with 1.0132, we will get 0.03 minus 0.03 PW equals to PW. So PW in that case, that is 1.03, PW equals to 0.03. So if we divide 0.03 by 1.03, so I will get PW equals to 0.03 bar. So the answer of the first part, that is partial pressure of water vapor, in that case will be 0.03 bar. Let's solve the second part, B. We have to find out dew point temperature. So dew point temperature. So now we are having PW, so we have to find out saturation temperature corresponding to PW. So we can write saturation temperature corresponding to PW, that is 0.03 bar. So temperature will be dew point temperature, and from steam table it is coming 24.1 degree centigrade. That is from steam table. So we know the saturation temperature corresponding to partial pressure of water vapor will be dew point temperature. So that's why I am writing TdP equals to 24.1 degree centigrade from steam table. Now let's take the part C, that is relative humidity. So for relative humidity, we are having the formula, that is PW by PS. So PS is corresponding to dry bulb temperature, that is 32 degree centigrade. So PS corresponds to 32 degree centigrade will be 0.048 bar. So if we plug the value here, we have already calculated PW, that is 0.03, and if we plug PS 0.048, so 5 we will get 0.625, or we can say that 62.5%. Now let's take the part D, that is the degree of saturation. The degree of saturation. For degree of saturation, we are having the following formula, that is W by Ws. So we can write PW, P minus PS, PS, P minus PW. So here we have to plug the values. PW I am having 0.03, P I am having 1.0132, PS that is 0.048, PS again 0.048, P 1.0132 minus PW 0.03. If we calculate this thing, then we will get 0.614. So the degree of saturation will come 0.614. Now let's take E part. We have to calculate the density of air in the mixture. So we are interested in density of air, means dry air in mixture. So now we are having the formula density of air is Pa divided by Ra into T dry bulk. So Pa, that is nothing but P minus Pw. So I can write P minus Pw, and Ra we know 0.287 for air, and dry bulb temperature we have to put in Kelvin, so 273 plus 32. So here P we know 1.0132 minus Pw 0.03 divided by 0.287 into 273 plus 32, and if we solve this thing we will get 1.12 kg per meter cube dry air. So the density of dry air in the mixture will come 1.12 kg per meter cube dry air. Let's solve the F part. In F part we have to find out density of vapor in the mixture. Density of vapor in the mixture. So density of vapor we can calculate easily because we know the specific humidity, that is 0.0186, that is kg of vapor per kg of dry air, and we know the density of dry air, that is 1.12 kg of dry air plus meter cube divided by meter cube of dry air. So now if we calculate this thing, we will get 0.021 kg of vapor per meter cube of dry air. So now let's take the last part, that is G part, enthalpy of the mixture. Enthalpy of the mixture. So for enthalpy of the mixture, we are having the formula HA plus WHW. So for HA, I can write Cp TA plus W. For HW, I can write Hg plus 1.88 T dry bulb minus T dew point. So now Cp we know 1.005, TA that is 32 plus W we are having 0.0186, Hg that is 2559.9, sometimes we are taking 2500.9 plus 1.88, that is 32, and dew point is 24.1. So now if we calculate this thing, it is coming 80.55 kilojoule per kg of dry air. So the enthalpy of mixture is coming 80.55 kilojoule per kg of dry air. And another interesting problem. So I am writing the problem here. Air at 20 degrees centigrade, 40% relative humidity is mixed adiabatically with air at 40 degrees centigrade, 40% relative humidity in the ratio of 1 kg of former with 2 kg of letter with 2 kg of letter on dry basis, on dry basis, find the final condition of air. Find the final condition of air. So this problem is basically based on adiabatic mixing of streams. So we can apply the formula related to adiabatic mixing of streams. So in that problem we have to use the psychrometry chart. So by psychrometry chart we can find out the specific humidity for both the streams. So first of all, find the specific humidity. So I am solving this problem here. From psychrometry chart, from psychrometric chart, I am having W1 that is corresponding to first stream, which is at 20 degrees centigrade and 40% relative humidity. I am having 0.0058, and for second stream I am having 0.0187 kilogram vapor per kg of dry air. Now similarly I can find H1 that is 35, H2 that is 90 kilojoule per kg dry air. So these things we can easily get from psychrometric chart. Adiabatic mixing of streams, we are having one relationship, that is W2 minus W3 divided by W3 minus W1 equals to H2 minus H3 divided by H3 minus H1 equals to G1 by G2. So now if we plug the value of W2 and W1 here, it is W2 is 0.0187 minus W3 by W3 minus W1 is 0.0058 equals to G1 by G2 equals to, we are having the value here, that is for G1 and G2 we are already having. G1 is 1 kilogram and G2 is 2. So from here I can write W3 equals to 2 by 3 into 0.187 plus 1 by 3 into 0.0058. So now we can easily get the value of W3, that is 0.0144 kilogram vapor per kg of dry air. So we got the value of W3. So now we are having the value of W3. We are interested in enthalpy of the mixture. So for enthalpy I can use H2 minus H3 divided by H3 minus H1 equals to G1 by G2 equals to 1 by 2. So now H2 I am having 90, H3 I have to calculate, H3 I have to calculate, H1 I am having 35 equals to 1 by 2. So for H3 I can write 2 by 3 into H2, that is 90, plus 1 by 3 into H1, that is 35. So now H3 will be 71.67 kilojoule per kg dry air. So now we can calculate easily the H3 and W3. So the final condition of air is W3, that is 0.0144 kilogram vapor per kg of dry air. and enthalpy of the mixture is 71.67 kilojoule per kg of dry air. Let's take another interesting problem. So I am writing the problem here first. For a hall to be air conditioned, to be air conditioned, the following conditions are given. The following conditions are given. Conditions are given. Outdoor condition. Outdoor condition. 40 degrees centigrade dry bulb temperature and 20 degrees centigrade wet bulb temperature. Required comfort condition. Required comfort condition. Condition 20 degrees centigrade, that is dry bulb temperature, and 60% relative humidity. Sitting capacity of hall. Sitting capacity of hall is given, that is 1500, and amount of outdoor air supplied. Amount of outdoor air supplied. Air supplied is 0.3 meter cube per minute per person. Per person. 0.3 meter cube per minute per person. If required condition, I am continuing this problem in next page. If the required condition, if the required condition is achieved first by adiabatic humidification, and then by cooling, So now estimate a capacity of cooling coil, in tons, B, the capacity of humidifier, in kilogram per hour. So now let's solve this problem. So from psychrometric chart we can get the following details. So I am writing from psychrometric chart, but in GATE examination they will directly give the values. So right now I am taking from psychrometric chart. In psychrometric chart, H1 and H2 given 57, H3 it is 42.0 kilojoule per kg dry air. Similarly, the specific humidity 0.0065, W2 and W3 is 0.0088 kilogram vapor per kg of dry air. T2 is given 34.5 degrees centigrade. Specific volume is given 0.896 meter cube per kg of dry air. So for this problem, I will just draw the psychrometry chart, and on that I will draw the process. So I am drawing the process here on this psychrometry chart. So here we are interested in W. Here we are having dry bulk temperature. So now this is point 1, this is point 2, and this one is point 3. So here we are having these three processes, these three steps, 1, 2, and 3. So here for 1 we are having W1, for 2 and 3 we are having W2 equals to W3. Similarly, it's a constant enthalpy line. It is a constant enthalpy line. So here we are having H1 equals to H2, and here we are having H3. And here at one point we are having a temperature that is 40 degrees centigrade. It is 40 degrees centigrade. And for 3 we are having at 20 degrees centigrade. So now we have to find out the capacity of cooling coils in terms and capacity of humidifier. So first of all, I will find amount of dry air supplied. First of all, I will find amount of dry air supplied, that is G. So for calculating G, we are having the sitting capacity of hall, that is 1500. We are having the amount of outdoor air supplied, that is 0.3 meter cube per minute per person, and we are having the specific volume, that is 0.896. So if we club all these things, that is 1500, it is the sitting capacity. If we multiply this thing with amount of air supplied per minute per person, so it will be 0.3 meter cube per minute per person. And now if we divide with the help of specific volume, that is 0.896, so we will get 502 kilogram per minute. So this is the amount of air supplied per minute, that is 502 kilogram per minute. Now we have to find out capacity of cooling coil. So we are having G, and if you see the cooling coil capacity, then we have to go from 2 to 3. So here we have to concentrate only on the process 2 to 3. So we are interested in enthalpy at 2 and enthalpy at 3. So we are having enthalpy at 2, enthalpy at 3. So we can easily find out capacity of the cooling coil. So now capacity of cooling coil can easily find out by G H2 minus H3. So we are already having G, we have calculated 502 kilogram per minute. H2 we are having 57, H3 we are having 42, and if we calculate this thing, so this thing will come, if we calculate this thing, that is 57 minus 42 into 502, so this one will come 7530. So 7530. So we can see what will be the unit here, because we are multiplying G, that is kilogram per minute. So I will write the unit here first, kilogram per minute into kg, kilojoule per kg of right here. So this one will be in kg per minute. So this thing will be in kg per minute. So we have to convert this thing into kg per second. So for kg per second, I have to multiply, I have to divide by 60. So this is for, this is for kilojoule per minute. And if we have to go for hour, like kilojoule per hour, so we have to multiply it with 60. So here if I multiply it with 60, I will get kilojoule per hour. So that is kilojoule per hour. And writing the capacity of cooling coil, capacity of cooling coil will be 7530 into 60, it is kilojoule per hour. So now if we divide this thing with 14,000, we will get in terms of ton. So 7530 into 60 divided by 14000, we will get in terms of ton. So I am having 7530 into 60 divided by 14000. So I will get 32.27 tons. So capacity of cooling coil will be 32.27 tons. Now we have to find out capacity of humidifier. So for capacity of humidifier, we have to see the process 1 to 2. So now we can take W2 minus W. That is the capacity of humidifier formula. Here W1 and W2 are specific humidity at 1 and 2. G we are already calculated. It is 502. W2 we are having 0.0088 and W1 we are having 0.0065. So if we calculate this thing will come in kilogram per minute. So here 502 into 23 into 10 to the power 4 into 60. So it will come in terms of kilogram per hour. So that is 69.3 kilogram per hour. So the capacity of humidifier is 69.3 kilogram per hour.